Okay, so let's discuss a question from hydraulic machines. So this is a question on a turbine where we get at one head we get a power of 6000 and the head is reduced without changing anything. So what is asked power? So how much is the power? Now the power is basically proportional to h to the power of 3 by 2. So this is something which we get from the dimensional analysis in the turbine. So P2 by P1 is nothing but H2 by H1 whole to the power of 3 by 2. Okay, so we need to get P2. So P1 we know it's 6000 at a head of about 36. So H2 is 24, the head is reduced, and now the initial head was 36, so 3 by 2. So this value we get close to 3265.98 kilowatts, 6000 kilowatts. So this was 32659. Now remember that, now you might be wondering how we get this equation. This we get from the dimensional analysis, but if you forgotten also we can derive this. Like if water is coming from a height h, okay, and then you have a nozzle which you have a, let's say a Pelton wheel kind of a structure. So the velocity here will be root 2gh, right? And that strikes the nozzle. Okay, the velocity that strikes the nozzle, so nozzle velocity will be increased by some factor, and so let's write k into k is the factor where the velocity of the nozzle is increased. I'm trying to derive this equation basically, but for this problem it is sufficient if you remember it, but I'm just trying to derive this equation. So now the momentum with which it hits the diamond is mb. So mass, so this is the momentum by time gives the force into the radius, okay, will give you the torque, and torque into omega is the power. So I just try to just drive it. Mass flow rate, m by t is mass flow rate, which is nothing but rho into q and v into r. Omega also I can write the rotational, it depends on the tip velocity. Okay, r omega is nothing but the tip velocity, which is u. Now the tip velocity of the blade is also a function of v, it's some ratio of v, so that we can write as v. So it's rho q and v square, whereas also this q, so this is some constant. Okay, now q again is a mass flow rate, which again depends on area of the nozzle into the velocity. So ultimately if we have everything a bigger constant, you get let's say you have everything into a bigger constant c. Okay, q is again proportional to v, so we get v cube. So power is like proportional to v cube, and v is, we know that v is again root 2gh, so it's h by 2, so h by 3 proportional to the entire proportionality constant into h by 3. So that is the reason. So from the Pelton wheel also you can just derive an equation. So remember that diameter has to be constant, then only you can apply this. So power is proportional to h by 3, keeping in mind that the other things are constant. Basically the diameter is constant. So for this equation, for this problem, you need to remember this equation. Otherwise, even if you forget, you can derive as we have highlighted here. Thank you. 3265.98 is the answer. Thank you.